So that previous portion was me rambling about how I keep on getting wrong in math learning when it's actually not my fault why it's wrong, and this is the program's fault because I know it's right because I double checked it with many different ways, and another person checked it too, which means this way is the correct way of doing it. So I don't know what's wrong with the program. I'll screenshot the program to show you what actually is happening. Let me get my this item. Oh, I already screenshotted it. Okay. So let me show you what's happening. All right. Upload image. What did wrong? So this problem over here, as you can see, I did the same thing. That's the right answer. I just don't know why I keep on getting it wrong. I'm gonna delete it, which means it's not my mistake. As it turns out, it is not. So yeah, this whole problem is a bust, so it doesn't really matter if I show it. And it doesn't matter if I show it anyways, because again, home apartments are not, you know, infinity pond anyways. So yeah, and again, as I said many times, I usually don't show the answers, but that one was crap because it was wrong. How can I not show something that's wrong? Um, that is correct. I don't know what the hell they thought of. So, moving to the next section, which is calculating this portion. Uh, we're gonna do, well, we're gonna keep on going. And this 20 minutes is me doing my homework early. So we're gonna continue this trend. But that's bound to happen because there wasn't, I need to email the teacher. And there's gonna be a lot of emails that means to the teacher about why this is wrong sooner or later. Which is going to be a pain in the ass for the teacher to deal with. Our professor, sorry, I should call him a professor because he's a professor. When the program is wrong, it's like, oh, well, who's the fault here? Not us. It's the program's fault. So the professor's going to have a headache soon. Um, yeah, our professor, that's what we should call it. So he's a doctor. I'm so glad no one knows about this. Yeah, yeah, that's fine. So I'm trying to calculate the FAP magnitude of this. That's easy, right? X and then Y. So we'll start with X. Oh shit, this is a particle. Particle is super simple. Where we do, you know the rules. Let's actually erase this shit. And then let's start by doing this first, like a normal man. X goes to here first, X is first, then E, so it's multiplied by 2X by the E to the X squared minus Y. Obviously, the 2E in protect is important to it. And then we just plus it by the opposite. So EX squared minus Y. That's the one portion done. And then we need the y version of it. As I said, ex squared minus y would be what happens because that's over here and it comes to go away, which is something like this. Now, I can't really show this without getting, what's the word, without showing everything. So we're going to not compute everything because I'm going to show you how to do it because you can because it would be telling you the answer at that point. So I'm purposely not doing it this way to show you that this and then this is needed. That will give you the answer. But this is after plugging in the p. So this is 0, this is 0. that's like 1, 1, 1, and then 1, 1, right? So that's a plus over here. That's 2. Oh, I can't show more than that because it would be just telling you the straight up answer at that point. And it's fine, it's not illegal, but I don't want to do it. I want you to learn. Therefore, it is empirical of me to not do that. I don't like doing that. And you should not do that too if you're trying to do. I mean, it depends on the question. If it's something that I don't give a crap that you care about. Let me this. Okay, let me try this again. Where did it go wrong here? X over here, 2x over here, 1, 0, that's 1. And then okay, that's right. Y negative. Oh, okay, that's negative. That's fine. I did wrong. Where'd I go? Am I doing this right? Let me clear this up a little bit. 2x 2. Oh, I'm doing it wrong. Sorry, I didn't register in my brain that it was 2 years, so it's 3 years old. Yeah, I'm right. Okay, so we got that right. And now find the rate of change in the direction of, so rate of change is next. In the direction of FP, which is over here. So what we need to do is we're trying to refuse the deal. Anyway, we're trying to make the rate of change when we go over here. So the derivative of everything, we have done what we did. So it's basically the magnitude of it. So yeah. Does that make sense? I don't know if that makes sense to you. But here's the general idea. So du of p parentheses equal this fp, and then the cosine, the angle. So what's happening here is that we're getting the magnitude, and we're going to get the cosine, let's say, so that like a tiny, like, you know, yeah. So yeah, there's actually 2 questions here. But that's how you do it. So yeah, that's okay. So the factor makes a 45 with the, yeah, basically that's what happens. So I multiply this by the angle that they gave. So they gave me 45. I will make up that's square root of 2 divided by 2 basically. Let me get my square root of 2 out. Square root of 2 divided by 2. That should give me the answer to all my questions there. So I got the answer right. So yeah, that's question number 9. Very easy. Very, very powerful question, actually. So yeah. I also would recommend you study your unit circle a lot. Unit circle comes in everywhere. So how else do I just want to describe this shenanigans? I showed you the 45-degree with 2 angles situation. How about if there's one more question here? Find the rate of change of f in the direction of the gradient. So what that means is just basically the magnitude, because this basically becomes 0 because it's a direction of the gradient. Does that make any sense? I hope it does. We'll discuss that later. Hopefully, we're gonna go to the next section, which is 14, because I've so much lost time. I waste so much time on that one question that was always wrong from the beginning. So we're gonna go with the next question. Wait a second, please work with me, computer. This question is f of x, y, and z equals the sine of x, y plus z at a point which equals to 0, comma, -2, comma, pi. Okay? So calculate to du which is the unit with the p over here. What is u? What is u? Is a unit vector of what? Of angle, making an angle of 30 degrees. So u equal a unit vector that equals 30 degrees. So we already know how to do this shenanigans. Um, right, right. Yeah, hopefully we do. Uh, there's a few ways to do this, but you know the magnitude of this question. So is a rule that this not too early like me. All right, we'll continue this question. So this is what happens, which equals to well the magnitude of this basically f change of f to p and then cosine of 30, and from a unit circle you should instantly get that. If you're, I mean, not instantly maybe, but if you look over here, 30 over here, I always remember that's the long side, so that must be square root of 3 divided by 2. So yep, that is what it is. Now let's continue this question by doing the dx equal, I guess not instantly. I wouldn't recommend memorizing that instantly. Um, yeah, b over here, that's y, so on top. So over here we have dy, which equals to x cosine xy plus z, and I should always cross it, always get confused. And then the last one is dz equal 1, so that's like a cosine of x y plus z. And as you can see, I write z differently sometimes. It depends on my mood. And then we know this. Oh shit, we're doing more unit circle shenanigans. All right, that's fun. That's so much fun. That's not fun at all. So this time I might need to write more down, just because I hate doing this shit in my head. So 0 plus pi, um, and then the square root of that. Let's do 0, right? So that's cancels everything out no matter what. So I don't have to worry about that one. And then cosine by, oh, I just realized that's going to be 0 no matter what. I just noticed that, man. They were nice enough with the questioning to do that. And if you don't know pi cosine, that's -1, but -1 doesn't matter because that's 4 plus like 1, I think. And then that's that, which equals square root of 5. Now you need to add that to the original unit vector, which I think you can get. I'm not gonna do. I'm gonna assume that you know how to do that portion, and then let me check my answers to see if they're actually viable answers, and then make sure this program doesn't screw me over. Divided by square root of. And then let's just do that. I'm not worried as long as I use my left hand, fan thumb, or whatever. I got it right. So that is the right way of doing it. So yeah, so get the original to this thing and let's plug into this portion up here, figure it out. You get it. I am not gonna say more because it would be apparent for me to say that I will plug in and then get real A and S. All right, that's the right answer. And then next question, please. Find the equation of the tangent line and the surface. We can do that real quickly. Make a video on that one real quick. 5x squared plus 2y squared plus b equal 26, and then p equals 2 comma 1 comma 1. Okay, parentheses. Okay, so we have this. So we have everything we need, actually. So let me erase this shit. Let me explain to you a little bit about this shit. So if I plug in this over here, 4, 20, that's 20, right? 1, 2, and then 1, 4 equals 26. Therefore, that means that if I was to get the original equation over here, the way that you're supposed to do something, so like, where was it? So you remember the plane, how it works? It means that these points indicates this part, so I don't need to put extra work into it. Does that make sense? No? Yes? Maybe? It'll make sense sooner or later when you look at the formula, which is consider f of x by a, b, c, comma, parentheses, comma, and then x minus a, and so on with the other digits. So y and z, and then over here would be 0. Now that kind of makes sense if that's true. It means that if I go back over here, the a over here is corresponded to these points, basically, to make the end over here possible. I hope that makes sense. Which means that if I want this, I need to get the dx, comma, you get the point. And since I want that very fast, I can get it very easily, right? By a 10x, comma, 4y, comma, 8z. Simple. Got it already. 1, 2, 3. Very fast. Should be ellipse. It's a 3D ellipse, which means it's an oval with a dome. It's kind of weird, but you'll get it if I show you more, I guess. Now what we do is 10x do this minus 2. Looks weird, but according to how, wait, I did this wrong. Oh shit, I did this wrong. No, wrong. No, I need to first plug in this to get 20, 4, and then 8. I knew something was, yeah, that's off. Okay, so because instead of double the digits, so it's kind of weird how that would be possible. So then we do 2 plus 4y minus 1, and then plus 8, where is it? I don't know, minus this one, equals 0. Now if I do 20x minus 40 plus 4y minus 4, still 8z minus 8 equals 0, then this should theoretically equal 26, which is, oh, it shouldn't. It should equal 20x plus 4y plus 8z equal 56, I think, which is multiply 2 version of that, right? And we multiply 3, I don't know. I did something wrong. Negative 12. No, 52, I think. Sorry. So yeah, it's 52. Yep. I'm okay with showing the answers on this one because you kind of need to. There's no way to say answer without doing that. So let me check if this answer is correct, and I'll come back to you real quick. So let me plug in, no, let's plug in this equation and hope for the best I got it right and didn't screw up. I'm not a screw up. I never was. Let me type this in real quick because I don't like to say that was right or wrong before I say. Actually, do like a right or wrong before I plug it in, otherwise I'm wasting my time sometimes. Well, not always. I'm right. Okay, good. That's the right answer. So I need to figure out a better way to show these problems without showing the answers because that's kind of like not the point of this question. But I am done